Okay. Order to start 4.4. I wanted to go over some of the highlights from 4.3. There's really only a couple things you really need to understand about the normal distribution in order to be really good at doing the questions, because all the questions are exactly the same. So I listed sort of the highlights from 4.3. I felt a little rushed in 4.3, so I just want to make sure we go over all of this so that when you attempt to do the homework in 4.3 or 4.4, you feel a little bit more prepared. So 4.4 is just a continuation of the same questions from 4.3 with just a little bit more practice. It's the idea of 4.4 is they want you to work with technology, which means they give you sets of data and you have to find the mean and standard deviation first, instead of just giving you the mean and standard deviation. Most likely for all intents and purposes in this class, I'm going to give you the mean and standard deviation. So I'm going to use it more as a practicing using the normal distribution. So basically what happens, and again, it's sometimes the notation is what causes some problems. We always start with a random variable x that belongs to a normal distribution with some sort of mean and some sort of standard deviation. Okay, it's always listed in this form. When you see the n there, that represents a normal distribution, because even though you're really at your infancy in learning about statistics, there are a ton of statistical distributions. So you have to be very careful that you're working within the right one. You know, there's dozens and dozens of statistical distributions, and we only really touch on 4 or 5 of them in this course. And the first one that we've talked about is the normal distribution. So that n doesn't seem important right now, but it will seem important because it represents the fact that we're using a normal distribution. Well, the problem is you can't just take data about any different subject and get a realistic answer. Like, you need to be able to compare it to something that's a standard. So we want to compare our x distribution to something called a z distribution, which is also normal, but has a preset mean of 0 and a preset standard deviation of 1. And that is what allows us to actually make a viable comparison between sets of data, or to just see where we lie. So the key is we have to convert our x values into z values. How do we do that is we use this specific formula. Okay, so this is going to become, if you're maybe making a list before we do the assignment or the quiz of important formulas in the unit, this is number 1. Okay, this is the one you need to know. The x value is the value you're given that you're analyzing. The mean is usually given to you. The standard deviation is usually given to you. Okay, so this is 2 sort of important little points. Now, once we find a z value, we have to use that to come up with a probability or a percentage chance that something can occur. So in order to do that, we're going to use something called a z-score table. And a z-score table shows up in your textbook on page 606 and 607. I'm also going to list one that's the same type. I'll list a PDF file where it's a single page. And basically, in the columns and rows, those are your z values. And in the guts of the chart, that's what we consider our percentages. So it starts as low as -3, basically, up to +3. That's, remember, a z-score table. When you look at the actual normal distribution of what it looks like, if it has a mean of 0 and standard deviation of 1, it goes anywhere from between -3 and 3. So basically almost 99.7% of the data lies between -3 and 3. And that's what all these numbers are telling you. They're telling you the percentage that lies less than a specific z value. So once you find your z value, you look it up in the table on page 606, and that'll tell you which percentage is less than that. Well, you have to be more cognizant of what the question is asking. Sometimes they're asking you what percentage, what's the probability z is less than a specific value, in which case you just look it up and it's the value in the book. If they're asking you for the probability it's greater than something, and I talked a little bit about this last time, so imagine you pick a specific z value and you want to find the probability it's greater, so it's over here. Well, because 100% of the data lies under this curve, if 20% lies up here, that means 80% lied down here. So if you're looking for this point, the back of the book will always give you the less than percentage. It'll give you the 80%. So if you're interested in the greater than, you have to do 100% minus the 80 to get that. So you always do 100%, which we represent with a 1, because we're doing percentages as decimals. And then we subtract the value in the back of the book. That will get us. So if you see that you have to do greater than, you're just going to convert it to 1 minus less than. And again, the less than is just the value in the book. Now the last option, and the one that kind of people find the most difficult, even though you follow the same method, you have two Z values. Say you have circle here and square here. Okay, I'm using just symbols, doesn't really matter what the number is. And you want to find the percentage that's in between those. Well, because the back of the book only gives you the less than, you're going to take whatever your larger value is, and you're going to find the probability is less than that. Well, that covers all of this area. What are you interested in? You're just interested in the red area. So you find the probability is less than the square, and then you have to subtract out the probability it's less than the circle. Then you get the red area. So you find the probability is less than the square, you subtract out the probability is less than the circle, you get the value in between. If you don't understand sort of what I'm trying to show you in the diagram here, just know if you're between two values, find the probability is less than the bigger one, find the probability is less than the smaller one, subtract them. It's the same method every single time. If you follow these steps, find a z-score, convert your x to a z, look the z up in the back of the book, adjust as necessary for greater than or in between, you'll have zero problems. All the questions are the same, they're just different numbers. Okay, there are a couple, again, these examples, take them for what they're worth. They give you a whole set of data and say, find the mean and standard deviation first. Well, if you have Excel on your computer, great. You can pump it in, find the mean, find the standard deviation, go. In the homework, there's a couple of questions like that. I can't assume you have all downloaded Microsoft Office, you all have Excel, you all know how to use the computer. So when I give you these questions, I'm going to give you the mean and standard deviation. Okay, so I'll do that one. When you look at the examples, it asks you to find them, but for the examples, I'm going to assume that they're given in the question. Okay, so I'm going to answer them maybe slightly different than the way they're answered in the note, but they're still the same questions with the same numbers, and you're able to go from there. Okay, so example 1 is going to imagine that it says this. You have a mean of 33.6, whatever the information happens to be about. These are machined bolts. Standard deviation of 0.3. They want you to find the probability that the length of the bolts is less than 33.9, but greater than 33.2. So they're really asking you this. Find the probability it's between 33.2 and 33.9. This is a between question. Okay? So between questions cause us a little bit more work because we now have to, we're not just finding one x value, we have to have two appropriate z values. We're doing two conversions. Okay? So this will be equivalent to coming up with changing two different x's into z's. So, for instance, if we look at this first one, if I want to find an appropriate z value for this, we plug it into the z-score formula. X value is always the one that's listed in the question, 33.2, minus the mean divided by 0.3. Get my calculator. 33.2 minus 33.6 divided by 0.3. Negative 1.33. Remember to go to two decimal places. So this is negative 1.33. The exact equivalent of this x value as a z value is negative 1.33. If you drew the two normal curves, you'd see they'd line up at the exact same spot. Okay, then if we go to this one.
Mommy, Cap told me an idiot.
Okay, I'm
then
filming.
you.
Guys, I'm making a lesson right now. Can you guys work it out?
That's not happening ever.
I'm filming. Can we work this out later?
And I'm like, I'm not
Okay, no one's
anybody
calling
nothing.
Okay, no one's calling anyone an idiot. They're fighting with the neighbor girl. They're social distance playing, and it's not really going that well. Okay, so we're finding a z-score for this one. We're also finding a z-score for this one. 33.9 minus 33.6 over 0.3. So Z is going to equal exactly 1 here, I believe. Okay, so we've converted both of our X values into Z values, and then you take the idea that I just showed you. You take the larger one, you find the probability is less than that. And then you subtract the probability that it is less than the smaller one. Okay, so you're really looking up two values in the back of the book. When you look up those two values, that'll give you your final answer. So the probability that Z is less than 1, we have to find 1.00. So these are all the negatives on this side. We go over to here. You go down the column first and look for 1.0. Because we don't have a second decimal place, we're going to use 1.00. And the value is 0.8413. Okay, 0.8413. Look it up in your Z-score table. Just make sure you're understanding how to use that table. It's very important. You look up the value negative 1.33 in the same table. The negatives are on this side. Negative 1.3. Then you go to the column with 0.03. That's negative 1.33. And it is at 0.0918. Okay, so it's basically 84% are less than 1, but 9% are less than negative 1.33. We subtract those values to find what's in between. So it's 0.7495. So basically 75% of the values are between 33.2 and 33.9 for the bolt size. Okay, so that's sort of what you're saying. 75%, if you round up, 74.95 are between the original, go back to your X values, 33.2 millimeters and 33.9 millimeters. Okay, so it's just an application of the same question over and over again. Do you have to find one Z value? Do you have to find two? Is it greater than? Is it less than? So if you keep practicing this exact same type of question, they're going to become much easier. Okay, in the note, there's a little aside here about discrete versus continuous data. I'm going to skip that for now because that is the purpose of the note in 4.5. So it's being introduced in 4.4, but it's not necessary to know in 4.4. So we'll just move ahead and go on to example 2. And then one more example and we'll be done. This is usually something that people get quite a bit better at when they practice, and this is a unit that people do well on, as long as they've put the effort in. So a manufacturer produces Smarties. A box is rejected if it has fewer than 100. The mean number of Smarties in a box is 107.3. So the mean number of Smarties in a single box, 107.3. Must be a giant freaking box of Smarties. Standard deviation is 4.6. Find the probability that's rejected. It says in the question, the probability it's rejected if there are less than 100 Smarties. Okay? So again, this is an X value. We want to convert this to a Z value. That's the first step. So somewhere along the lines, and you can do it above, you can do it below, you can do it beside, doesn't really matter. You're taking this X value and you're converting it to a Z value. Okay, so the X value is 100 minus 107.3 divided by 4.6 to 2 decimal places if possible. 100 minus 107.3 divided by 4.6, negative 1.59. Okay, make sure you're rounding. So this was negative 1.586. So I round up to negative 1.59. Now you take a look and you say, what it's asking me to find is less than. That is what the chart gives you. That's the most straightforward case when it's less than. So you are simply required to look negative 1.59 up in the book and get an answer. And then the question is essentially done. So negative 1.5 I look at. Then I have to go to a second decimal place of 0.09. Negative 1.59. Use your book to make sure you're doing it at the same time. 0.0559. Okay, so that's saying they reject less than 6% of boxes of Smarties. All the rest are good for sale. If they had 99 or 98 Smarties, they'd be rejected, anything less. So that was part A. Now part B says out of 10,000 boxes of Smarties, how many get rejected? Okay, well, we know 5.59% get rejected. So we take the 10%, we multiply, or 10, we take the 10,000, we multiply it by the percentage that get rejected. And when you multiply that, you get 5,590 boxes are rejected. Wonder what they do with those. Maybe you eat them, I don't know. Maybe they give them to the workers. Maybe they redistribute the Smarties in. Okay, so just be aware, when you're given a full number, you can take the percentage and apply it to any number. If they said they were producing 1 million boxes of Smarties, you could find out. If they're producing 800 boxes of Smarties, you still multiply by the same percentage, 5.59%. Gives you an exact number that gets rejected. Okay, example 3, which I guess I can do right here. They must have made up from their fight. I can hear them laughing now. Okay, example 3. The list below gives the number of patrons per day over a 30-day period during July at a theater. Not your July. No one's going to any theaters anytime soon. Assume that it approximates a normal distribution. Find the mean and standard deviation. Well, again, I told you I'm not going to make you find the mean and standard deviation. So if I had been doing this in class, I would have highlighted the data, put it into Excel. We would do a whole computer component of how to do this with a program called Fathom. It would spit out these answers for us. Okay? The second question is find the probability that there will be at least, probability there are at least, so greater than or equal to 178 patrons on any single day. Well, remember that greater than is a little bit of a problem. The back of the book gives us less than. So we really need to look at this and say this is going to be 1 minus the probability is less than. Okay, so if 20% are greater than, then, or less than, then 1 minus 20% would be 80%. That'll be greater than. So anytime you see greater than or greater than or equal to, you have to use this 1 minus to convert it to that. Within this, you keep the 1 there. You still have to convert this to a z. Okay, this x has to become a z. And again, you're doing the same sort of thing. You're taking this value, you can do it on at the side, x minus x bar over sigma, in this case 178 minus 151.6 divided by 23.3, and you get 1.13. So you are simply trying to find the probability it's less than 1.13. Don't forget the poor 1 that's sitting here. Then you look up the value in the book. Again, it's a positive. It's going to be on the right side. So you're looking up 1.1, and then you go over to 0.03. So 1.103 is 0.8708. So this was telling you that 87% is less than that. We want to know how much is greater than that. So 1 minus 0.8708, 12 and a bit percent, is 0.1292. Okay, so almost 13%. This kind of means approximately 13% of the days there was more than 178 people that went to that theater. You will notice in the homework that I have listed, there's a need for technology for a couple of them. So if you have it, you'll have to somehow come up with a mean and standard deviation of a set of data, pump it into Excel. You can do it. I showed you in chapter 3 what the commands are, but if not, you can just Google how to do it. There was something in 4.3 that I didn't really get a chance to go over, and that was the word percentile. So I just want to kind of talk about that definition for a moment before we finish here. Okay, what you really want to do is just practice these z-scores. Practice using the table. Your quiz on Friday is going to be a lot of z-score stuff. So you're finding specific z-scores or you're finding specific things. It's going to be a little bit math skilled based, so make sure you practice because we have to assess you still and do a little bit of work here. So in terms of what is a percentile, there was a definition in 4.3. So the exact definition, the kth percentile is Okay, so in terms of a percentile, the kth percentile is the data value that is greater than k% of the population. So imagine you have a spot here and you're looking underneath. I'm going to use 80 because I've been using it a lot. If 80% of the data falls in this area, then this point here is considered the 80th percentile. Okay, the kth percentile, the 80th in this case percentile, so we're replacing this with 80th. The 80th percentile is the data value that is greater than 80% of the population. You'll notice 80% is below there. Now, when you're talking about percentiles, these are the numbers in what I call the guts of the Z-score table. So when you look at a Z-score table, let's just pick one side of it. It looks like this. There are values here starting at, say, negative 2.9, negative 2.8, negative 2.7, yada, yada, yada. And over here you have 0.00, 0.01, 0.02, so on and so forth. Well, the black values are your Z values. The numbers in here, any value you have here that you're coming up with, are your percentile values. So if you're trying to find something, say I'm looking for the, what's a good one here? Whatever, say I'm looking for the 75th percentile. What I'm looking for is a Z-score that corresponds to the 75th percentile. So I'm looking for the number in the guts of the chart, so in this main body, that is as close to 0.7500 as I can find. That's my goal. So they do go in order. These are small numbers on the left, larger numbers on the right. You'll get close to 100%. So I'm looking for this closest value I can find to 0.75. And I find two values that are close. I find 0.7486, and then the next one beside it is 0.7517. So you have to know which one is closer to 0.75. Well, if you look, this one is 14 one-thousandths away, right? If you go 14 above, you get to 0.75. This one is 17 one-thousandths away. So this is the value that's closer to, that's the closest one to 75th percentile as possible. So if I trace that backwards, so if I go from that value, 0.7486, and I trace it backwards, it goes to a Z-score of 0.67. Okay, if I have a Z-score, I then may be able to use that to find an X value if I'm given a mean and a standard deviation. So I believe that's going to pop up in the homework. That's working backwards. So you do have to understand the definition of a percentile so that you can work backwards. I'll go over a little bit more of this in 4.5. This won't be as big of a requirement on the quiz on Friday, but for sure we'll talk about percentiles when we get to the assignment next week. Okay, I don't know. I have such mixed emotions about the fact that it looks more than likely that we're not going back to school and that I won't see you guys again. So it's hard to stay motivated, honestly, to teach. I'm sure it's very hard for you guys to stay motivated to learn. Everyone has sort of their own things going on right now, and we all have families that need taken care of, including you guys. So, I mean, hang in there. I'm trying the best I can to not make this too overwhelming an experience. So if we stick to kind of 2 lessons a week and an assessment every other week, maybe, basically for the assignments, and then one little quiz, which I don't think is too daunting, then that's what we'll have to do. The unfortunate part for you guys is of all the courses that are being offered, they really are putting the most pressure that we finish the grade 12 ones. So that's sort of the scenario. We have to get done as much as we can get done because life is going to move on at some point, and you guys are going to move on from us, and I would feel terrible if we didn't make our best effort to prepare you for post-secondary or prepare you even to return to us next year. So in the end, we all have to make sacrifices during this time. So stick with it, please, as much as you can. It's for your own benefit, believe me. Give yourself some routine, do a little bit of work. Probably not you guys. I always like doing math homework, so it's sort of a nice thing to do. But we're in a phase now where I can see everyone's getting a little tired of this, including myself. So I got to force myself to come out here and teach this. So force yourself to get down to business and get it done. Good. I miss you guys. I wish we could go back to school, believe me. Everyone needs a little bit of work in their lives, but so far so good. Okay, we will see you next week.